Today, we begin one of the most important foundations of artificial intelligence, supervised learning. Learning from labeled data. This is the learning with a teacher. A data set gives both the question and the correct answer. The model learns the pattern between them. Machine learning landscape. Machine learning has three main branches: supervised learning, unsupervised learning, reinforcement learning. Supervised learning is learning with labeled data. Unsupervised learning is discovering structure in raw data. Reinforcement learning is learning by trial and error. Today, we are here in supervised learning. Core mechanism. At its heart, supervised learning is simple. Input X goes into a model. The model produces output Y. The goal is to learn the function fx is equals to y. The model is like a student. The data set is the teacher. A data set is a structured collection of input, output, and pairs. For example, house size, number of bedroom, location score, and output price. Every row is one example. This structured format becomes a data matrix. Features versus label. Features are the input. They are independent variables. Labels are output. They are target variables. The model uses features to predict the label. Remember, features is equals to questions, label is equals to answers. Training versus testing. We never train on all the data. We split the data, usually 80% training, 20% testing. Training set teaches the model, testing set evaluates it, like study guide versus final exam. Two types of supervised learning. There are two major types: regression and classification. Regression predicts quantities, classification predicts categories. Regression predicts continuous numbers. Example: house prices, stock values, temperature. Linear regression is a classical algorithm here. The output is a number. Classification. Classification predicts discrete categories: spam or not spam, tumor or benign, fraud or safe. Algorithm includes logical regression, decision tree. The output is a category. A model is simply a mathematical function. Input x goes into function fx, transforms it, output y comes out. Training means adjusting that function. Goal: minimize the difference between predicted y and actual y. What is loss? Loss measures how wrong the model is. High loss means poor prediction. Low loss means accurate prediction. Common metrics means squared error. Loss is like an exam score. Overfitting. Overfitting happens when model memorizes instead of understanding. It performs perfectly on training data but fails on new data. Good models generalize. They understand the patterns, not answers. Real-world application. Supervised learning powers spam detection, credit scoring, face recognition, medical diagnosis, recommendation systems. It is everywhere. Supervised learning versus clustering. Supervised learning has labels, clustering does not. Supervised predicts specific output, clustering discovers groups. Supervised is learning with a teacher, clustering is self-guided study. Let's summarize. Data plus label is the teacher, model plus optimization is the student, loss function is the exam grade, that is supervised learning. In the next lecture, we go deeper in regression. Thank you.